Okay, so I want to talk about 12.5, which is specifically titled Algebra of Functions, but the thing I really want to get to is this thing called function composition. Okay? This is a very cool thing, and we've actually been using it all along. So don't be scared. This isn't something new. It's actually just the same thing in a kind of new context. So I'm going to give you a new word for it, basically. So way back when we had a function, right? And that was a rule that took something and turned it into something else, right? So maybe we thought about taking x's and turning them into y's or whatever, right? Or like we were just doing, we had times and we turned them into populations. Now there's this other idea that, okay, so if I went from x to y, what if I also happen to have, like, just laying around, right, a way to turn y's into something else? You guys see that? So like I had this one laying, like this one was just kind of what I was doing. But then also like kind of laying around in the background, there was another function g that turns y's into, I don't know,
X, Y, and Z.
z's or something, maybe? You see that? So then I might ask about, what about the rule that I get by doing f first and then doing g? You guys see that? Do you remember this diagram a little bit? When did we see this diagram?
Breaking down the interior parts of the function.
Yeah, when we were doing kind of, okay, we wanted to think about what a function did, and then we wanted to invert it, right? So before we would have said, okay, this is the rule I'm talking about, right? This is my kind of function that I'm interested in inverting. And then I'd go back and do each of these pieces backwards, right? Today we're just talking about the forward direction, and I'm just going to give this thing a name. That's really all function composition is. It's just a name for this thing that's made by doing f first, then g. You guys cool with that? We're going to call that thing g composed with f. Okay, so I'm defining really just this little circle symbol. So I'm saying g, little circle, f, right, is a function you get by doing which one do I do first?
F.
Yeah, it's got to start over here, right? So I do f first, then g. So by doing f, then, then doing g. You guys see that? So if I was to write this rule as my kind of usual rule name, right? I'd call this g composed with f of x. Or I might even do that in a different way. I might say instead, what if I take an x, if I put that into f, right? So I take an x, I put that into f,
And then put that into G.
and then I feed that to g. You guys see that?
C, and so on and so forth.
Yeah, and then if we had more functions, we could feed it to further things. You guys see this?
Yes.
So for example, right,
Function, a function, a function, a function.
if I had one of my kind of old like line functions, so I might have L of x is 2x plus 3, right? If we were trying to invert 2x plus 3, we might think of this as what? What do we do first to an x?
Subtract 3.
Yeah, we multiply by 2.
F, F.
So if I'm putting an x in, right? I multiply by 2, I get something else, then I add 3, right? You guys see that? Here's my 2x plus 3 across the top, right? That's my L.
We're just naming each part of the,
Yeah, we're just naming the pieces. So really this is me just saying, okay, I've got L of x is 2x plus 3. I could think of that as if f of x is 2x and h of x is x plus 3, then I could replace my object L of x, right? I could think of that as first doing f, then doing,
where really x in h of x is f of x.
yeah. So first things first, I need to do f and then do h. You guys see that? So I could think about this as h of f of x. You guys kind of see that? And if I wanted to write that with my new cool symbol, I would write that as h composed with f of x. You guys see that? So what have I actually changed here?
Absolutely not.
Yeah, really, there's nothing new under the sun here. The only thing we're looking at is this.
You're just giving it names.
Yeah, I'm giving this symbol a name and a way to say it. Right? So I'm giving the idea of stick two functions together, a name and a phrase. Here's the name, right? H little circle f. And the phrase is, this is H composed with F. You guys see that? Okay. Should we try another example? Break one up a bit. Okay, so here's a function. Maybe I don't want to use f. Let's call it w of x. And w of x is going to be the square root of x plus 1 minus 3. You guys okay with this? Okay, so if I put an x in, what's the first thing I do to it?
Add 1.
Okay, so I'm thinking, okay, I start with x's, add 1 is the first thing,
Root.
then we apply the square root, then we
Subtract 3.
subtract 3. You guys see this? Anna? Okay, so maybe I want to write this thing as a function composition, right? So I should name these 3 pieces. What do you want to name them? You get to
A,
pick.
B, and C.
A, B, and C? Okay, sure. So this rule is A of x equals,
Equals the next x. So
wait, how do I write a formula for, okay, good. Right, this is the add 1 function. If I want to write a formula for add 1, I write A of an input is the input plus 1, right? Okay, what's B of x?
the root of x.
Root of x, right? I take an input, right, whatever input I'm putting in there, and I just take its square root. That's all that thing does, right? Okay, how about this guy? What's C of x?
X minus 3.
Okay, that's x minus 3. Okay, so if I wanted to write w as a composition of functions, how would I write w?
A of B of C of X
So close.
would be A,
It's-
parentheses B, parentheses C, parentheses X, right?
So close. You guys see that?
It's C.
These are a little bit confusing because I have to think inside out, right? Because things start happening at the inside near the x, right? So if I want to think about this and the way I get these right, because I do this same backwards thing that you guys do, the way I think about it to get it right is I think, okay, I start with an x, and then what's the first thing I do to it?
Add
A.
1, you do A.
I do a to it. And then after I've done a to it, I'm here. So now what am I doing to it? B to that, right? B to that whole thing. And then C to the whole thing. And this is awkward notation, right? You guys see that? The reason I really wanted to introduce my new symbol was so that I didn't have to do all this parenthesis business. Right? So if I want to write this in a slightly more elegant way, I could use my new toy. So how do I use my new toy?
Would that be C circle, B circle, A of X?
Okay, I'm doing C composed with B composed with A to X. Okay, see that? This is just a new way to name rules, right? If you've got two old rules and you want to name the rule that you get out of doing one and then the other, this is just a nice convention for that name. Right? Otherwise, you'd have to like write a little paragraph explaining which one you do first and then second. Now I've just got a nice symbol, so I can say, oh, this is C composed with B composed with A. Bam, done. Cool.
And I think I got that part though.
Okay, so when we were doing inverses,
No, I meant I didn't write that part down.
Okay.
On the bottom right. Or, yeah.
are you good now?
Yeah.
Okay, are there any other questions about this? This is really just a method of writing, yeah?
Yes.
And a usefulness of this method is that when we're doing inverses, right? If I wanted to invert a function like this, what do? I do the opposite pieces in the reverse order, right? And then as long as I can do each of those, I can construct an inverse. You guys see that? This gives me a nice convenient way to say, okay, if I'm going to do this thing backwards, right? I got to do C's backwards first, then B's backwards, then A's backwards. You guys all see that? Just gives me a nice naming convention. Cool?